All right. Hey, everyone. Welcome to the Kubernetes SIG IBM Cloud meeting today on November 7, 2018. My name is Sadeh Zala. I am one of the SIG leads and also your meeting host for today. As always, please keep in mind that this is a public meeting and it's being recorded. We'll make this recording available on YouTube, so be considerate of what you speak about. The agenda is in the chat, and if you have anything to add, please add there. We have Khalid, IBM DE, working on ICP, talking about IBM Multi-Cloud Manager today as part of our regular meeting overview in the beginning kind of theme. And then we'll have other things to be discussed afterwards. So with that, Khalid,
Sure. Yep. I'll just give a quick overview of the IBM Multi-Cloud Manager. So this was a product that was announced, I guess, a few weeks back at the Forrester show by our CEO, Ginny. What it's really doing is recognizing the fact that, Kubernetes is getting very pervasive now in enterprises, and it's also recognizing that people are deploying Kubernetes not just on-prem or on the cloud, but are developing and deploying applications that span different cloud providers, and they need a tool. And as the pervasiveness of Kubernetes increases, the number of Kubernetes clusters grows, and you're growing them for a variety of reasons, whether it's for dev test environments or for different business units or for different geographic locations and so on, or on your premise or on your cloud provider. That poses new challenges that need to be handled, and that's what the multi-cloud manager is intended to address, right? So this is kind of a high-level view of the main areas of focus. First is around the kind of visibility of what's going on in your Kubernetes environments that are, again, distributed in different locations, and for whatever reason, so you decided to deploy multiple clusters, and you need to have visibility into them, what's going on, and being able to do various operations on them. Another key area challenges as Kubernetes clusters themselves start to proliferate is in the area of governance, right? How do I ensure my environments are configured consistently and correctly? Are they compliant with my various policies for configuration and state and those kinds of things? And the last area, again, is around automation, right, of your Kubernetes environments, and how you deploy applications on them and manage their life cycle, how you manage the clusters themselves, how do you upgrade them, and so on. Okay, so what I'm going to do is kind of switch over to the view of from the UI perspective, and I'll talk as I go through this how we are leveraging Kubernetes and extending it to actually make Kubernetes itself as a foundation of managing multiple clusters of Kubernetes that are potentially in different locations and different cloud providers. So one of the components that we use in the Kubernetes ecosystem is the cluster registry, right? And what you're seeing here is kind of a view of multiple clusters that are located in different zones or different regions and so on, and they're all tagged by various labels, like for data center, for environment, and which region it's in, and so on. So you see, I have clusters for development for my social applications and web applications and so on. I have some clusters that are on IBM Cloud, and some of them are on AWS, and so on. Now, the first phase of the multi-cloud manager deals with self-managed clusters. In the next phase, we're going to be extending it out to managed Kubernetes services such as IKS and so on. Okay. Now, what you're seeing here is we extended the cluster registry to that's the open source project to be able to get some visibility into what's going on in your cluster. So high-level aggregation summaries of the state of the clusters in terms of the nodes, memory, CPU utilization, and whatnot. So this is kind of from a UI perspective. From a command line perspective, this multi-cloud manager exposes its functionality as a set of Kubernetes APIs and custom resources. So I basically point to a one Kubernetes cluster, and I'm able to do a kube control, get clusters, all namespaces, right? So the same information that I'm displaying by the UI is available as Kubernetes resources, right? And you can do kube control, describe, let's say this cluster, and minus n. And you get the extended attributes, and doesn't have a resource type. Describe, so show dev1. Okay. Okay, let me just skip that, right? I think the syntax I'm probably just getting wrong.
Yeah, I think you can just add cluster.
Yeah. Cluster. Okay, yeah, you caught my mistake. Yeah. Right. Okay. There you go. Right. So here you get more details about that cluster and what's going on and so on. So it's all accessible by the Kubernetes APIs. Right. So that's kind of the high-level inventory of clusters that you get, and basically what you do to get a cluster to be managed by the multi-cloud manager is you install an agent. We call it a clusterlet, similar to a kubelet in Kubernetes that manages an individual node. A clusterlet manages a cluster and connects that cluster to this multi-cloud manager. We use the notion of a hub cluster that is the central point of management for multiple clusters. So this is one view. We also have kind of a dashboard view as well that gives you summary information from a kind of just a visibility perspective. Of course, it takes a little bit of time when you're doing the demo. Otherwise, it was reasonably fast when I was testing it a little while ago. But anyway, this gives you, a summary of the cluster health and the pod health and the Helm releases and those kinds of things. And you can drill into it saying, okay, I have 2 pods that are failed and not running. I can go in and drill into the pods and find out that they're, not running in a particular cluster within my environment and what they failed and so on. So it helps in getting that visibility aspects of things. You also have, visibility into the underlying infrastructure, things like the nodes that make up your clusters, and you have, ability to see the versions that you're running, and you see we're running some on just plain ICP, some are actually running with ICP on an OpenShift environment. So kind of embracing Kubernetes in whatever form and wherever it exists. And you see some nodes are Power and some nodes are x86 and whatnot. So we embrace all the architecture. We embrace, Kubernetes wherever it exists in this multi-cloud manager, right? Similarly, you get a view of the storage, the underlying persistent volumes and volume claims. You can have a view of this across your clustered environment or your multi-cluster, multi-cloud environment from one, central management point of view. Okay, so that gives you some level of visibility. Now, what we have on top of it is kind of a way of managing workloads. So starting with things like Helm releases, we're able to expose that and see the Helm releases that have been deployed in the different clusters, and you can actually go into the catalog and let's see. Let's pick a Liberty application, Liberty, right? And I can, from one management point, I can deploy out to multiple clusters. So let me just call it test. Select a namespace, and I can select a remote install. So we extended the Helm catalog to allow you to be able to select which target clusters that you wanted to deploy on. So I'm just deploying it on the AWS cluster. So from a point of view of individual Helm charts, you can deploy it out in your environment. A test, so you can see that this was deployed in this web prod AWS cluster, and if I went to that cluster, I'd see the pods running there, right? So what we, a couple of other kind of features, capabilities where we extend the Kubernetes model is in the area of deployment of applications and workloads. So the application concept is something that is emerging in the Kubernetes space. There's a notion of, as part of the SIG application working group, they have this notion of an application, and this is the YAML for it, right? That allows you to group pods or other Kubernetes resources. So this is grouping pods. It could be any other Kubernetes resource, and group them by various labels, right? So here we're just using the app label with a set of allowable values. So this kind of guestbook app has a app server component and a data server component with the Redis master and a Redis slave. So you're grouping all these together into one kind of application. Now, what we have done, beyond what the SIG app community CRD has, is to be able to extend it with some notions of deployment, right? So each of these components, even though they're separate from a logical perspective, are grouped into this one app, and the deployment of it is specified here. Again, we're using a Kubernetes CRD with a kind of deployable with parameters, specification parameters that allow you to specify the Helm chart and even other default values and so on for your values file that you can specify, right? So each of these components that are part of the application are deployable components that get deployed together as when the application gets deployed. And you also have kind of a view of the runtime topology of these applications. So right now, this application is deployed on one cluster within that inventory of clusters, and it has these components: a slave component, a master component, and a controller. Okay, and what we also have is go back here is the ability to generate dashboards for these apps. So we're leveraging the Grafana and Prometheus to collect and aggregate information for the app and be able to generate a dashboard that shows summary metrics about CPU, memory usage, and network I/O for that app in context, right? In context of the cluster that it is running on. So you get some information about the cluster as well as the components that make up the app. So the Redis master and the Redis slave and the web component and so on. So you get automatically generation of dashboards for that app. One of the other components that we have in the app is the notion where we extended Kubernetes is this notion of placement policy. I'll show this through the CLI. So group control get placement policies. Right. So for this demo guestbook app, we have a placement policy that indicates where that app should be deployed. Right now, we're saying, it has a replica of 1, and it's has been deployed on web dev 1. I can go in and control, edit placement policies, give it a name. Right. So I can change the deployment. So let's say I'm an SRE or that kind of thing. I've deployed this app in one cluster, but I want to increase the number of replicas to 2, right? So that it gets deployed on multiple clusters. And if there are multiple clusters that meet this requirement, so we're using a cluster selector with labels to say, target all clusters in Ohio within the dev environment, and create 2 replicas of this application, and order my clusters by CPU utilization as my selection criteria. Again, similar to how the Kubernetes scheduler does it, within one cluster, where you have filters that select a particular type of node, and ordering criteria that picks the best node. We have the same concept, but extended to multiple clusters. So if I edit this placement policies, increase the replicas, then I go back and get the placement policies again. The number of replicas has been increased, and we have a controller basically, monitoring these placement policies and making decisions about where to place the workload. So now the decision is that it's on web dev 1 and web dev 2, right? So what happens is that, the placement policy increases the number of instances, and then maybe it takes a little bit of time, right? And let's go back. So this topology view should show that, okay, now I have this components also running in not only web dev 1 and web dev 2, and you see the components there. And if I had some, traffic hitting it, you'd see, the arrows being part of that, right? And if you go into the dashboard, let me see if it's, I have to do a refresh here, right? So the dashboard, again, automatically is updated based on the context of the cluster, right? So I have not only on web dev 1, but I also have it on web dev 2. So I can see the components of the app, and it takes a little while for some of the Prometheus metrics to be filtered up to the federated Prometheus at the top level. But you can see that now my application is actually running with 2 instances in multiple clusters. Okay. So that's from a application deployment and automation point of view. From compliance and configuration checking point of view, we introduced the notion of policies. And again, what we've done is extended the Kubernetes constructs to allow you to define policies that in Kubernetes YAML as custom resources. And what this policy does in this case is an example of a role template, which says that within my clusters that match whichever ones I target using the cluster selector, basically it says that it must have a particular role within that cluster. So it must have an operator role, right? And that operator role must have these access to these APIs and these resources with these verbs, right? And you can also have another type of compliance check where you say that it must not have a particular thing, right? So both the notion of being configured in a certain way with a certain attribute or a certain set of attributes, or being configured without those attributes is supported in this model. And we're extending this to, right now it deals with Kubernetes roles and role bindings. We're extending it to other resources so that they can also be managed, right? So this basically what happens is that this policy is enforced continuously by the agent running within that cluster. So if I did a kube control get roles, so I have this operator role that was created. And because I have a must-have policy, if let's say, accidentally, deleted that role or maliciously somebody went in and deleted that role, operator, right? What will happen is that controller in the back end detects that, and it should recreate that role within that cluster. So you see this is 9 seconds old. So there's a controller there that's monitoring the status of the configuration of each cluster and is able to take actions to restore that configuration state to what that desired state was within this environment. Okay. So that's kind of the policy management. And again, this is the first version that we came out with, and we'll be extending this to other areas, including things like being able to forward events into an event management capability, and also being able to, we can, even in this current version, secure access to these clusters so that only based on RBAC rules, only certain users are able to do certain operations within those clusters. Okay. So that's kind of a quick overview of the multi-cloud manager. Hope that's useful. If there's any questions, comments, you can share them with me, or you can ask in the Slack channel.
Yeah, I have some questions. Thanks, Kali, for the wonderful demo. So the first question I have is, it seems a little similar as some of the requirements are similar, like the federation.
Mm-hmm. Yep.
What's the basic difference?
Yeah, so we are leveraging some of the federation capabilities in here. I talked about the cluster registry. Federation deals with kind of propagation of Kubernetes resources, like deployments and those kinds of things. It doesn't provide a kind of a central visibility into all those resources. So what we're doing is augmenting the Kubernetes federation capabilities in this multi-cluster, multi-cloud manager. It doesn't deal with the policy management capabilities per se. It doesn't deal with the Helm chart-based deployments or this application concept. But over time, I think what you'll see is us leveraging more and more components of the Kube Federation, especially the V2 stuff. And bringing that into this. We are committed to, leveraging what the community is doing and the standards that are forming around it. It's just at this point in time, the Kube Federation is still kind of alpha, and we, like I said, we leverage certain components of it, and we'll be adding more of those components over time to kind of complement what we're doing with the multi-cloud manager.
Okay.
Khalid, yep.
Thank you.
Khalid, then I guess we are also contributing to the community in V2 work, right? Part of what we're doing here.
Yep. We have a couple of people that are participating in that Kube Federation V2, right? And also in the SIG app, as well as in some of the policy working groups.
The cluster registry, yeah, that's what I was actually adding in a minute. So, okay.
Yep.
Okay, yeah, that's great. Actually, we'll be talking a little bit about those work in the SIG presentation next week at KubeCon.
Yep.
Yeah, another question I'm curious is on the scheduling part. So basically, if we only have one cluster, right? The default scheduler, if you say you want to deploy multiple paths across zones. So the default scheduler is responsible for that, and
Correct.
it knows the entire status of the whole cluster. So what the status in the multi-cloud manager? So do you have a separate scheduler running there to know the status of the whole?
Correct. Yeah. So there's a scheduling functionality. Like we haven't split it out into a specific scheduler just for like similar to the Kubernetes scheduler, but that would be something that we would look at going forward. But there is a controller which does the scheduling of the applications. So whenever you deploy your application into your environment, into the multi-cloud environment, it will pick the clusters where to target those applications based on your placement policy.
Okay, does that mean so the whole application should be put into a single cluster, not cross cluster? Okay.
You can, if you can have multiple placement policies for different components of your application, but in the current case that we support, it's one instances of your application in a cluster at a time. We are extending that to be able to say you can have components of your cluster that span or components of your application that are in one cluster and another component that is in another cluster. We're also looking at Istio and multi-cluster Istio as a way of helping you to move components of your application in a seamless way, right? So those we're participating in all those communities to kind of help drive those use cases, again based on some of our client engagements and some of the things that we see.
Yeah, thank you. Yeah, according to my understanding, right now, if you want to support that application to have different paths running in different cloud cluster, that would be a little challenging because your scheduler have to know the entire status of the multiple clusters.
Well, it does, right? As I showed you, you can get when you do the kube control, or even in here, you from the point of view of the application or the application scheduler, it has knowledge of all these clusters, right, that are listed here. So it can target, and it has knowledge of the CPU memory utilization at an aggregate level. So it can make some coarse grain decisions, but it doesn't target particular nodes within that cluster for pods. That would be delegated to the Kubernetes scheduler inside that cluster, if that makes sense.
Okay, makes sense. Yeah.
Okay. Okay, let me pause here and no other questions. Okay. We can move on to other topics.
Yes, sir. Yep. Thank you so much, Khalid. That was great. Yeah. So a couple just quick topics here. More like the first one, I just wanted to sort of little announcement here that next week the larger community meeting, which is every Thursday every week, is happening next week as well. I guess even though there is a KubeCon Shanghai, they decided to continue the meeting. And we have our turn for SIG updates in the meeting. So thanks to Richard. He will be giving the updates to the community next week. I'll be in Shanghai for KubeCon, and that was the next topic added in the agenda. So we have two presentations, 35 to 40 minutes each, one for introduction, one for deep dive, and just for a little, brainstorming if we need to make any change here. But right now the structure for presentation is more like an overview for the SIG, the structure of the SIG, and why would somebody like to join the SIG, right? So that's one of the things I think I would like to emphasize there, depending on the audience and in general, inside outside the CUBE meetings, that we would like to have more folks join these discussions. So some of the benefits of joining this SIG, like all these great things we hear, right, from the leaders in the IBM cloud space, on the IKS side and the ICP sides, the discussions around Kubernetes. And then we're going to have some slides on overall cloud strategy, which is motivation behind the SIG, right? IKS and ICP overviews kind of things. The contributions we are making to the communities, not just PR, but creating the issues, participating in discussions, right, in different working groups and SIG. Some of the things, Khalid, you mentioned around the cluster registry, federated V2 work, SIG app work. This is not of what IBM is contributing overall, the open source team, but more from the cloud team perspective. So ICP side, from IKS side. And then we will basically wrap up the talk with the near-term roadmap. So this is more for like deep dive session. I'll talk a little bit on the cloud provider code from our side, some of the progress we have made there, or though it's work in progress, I would say, that Richard is doing to open source the cloud provider code we have. So the process is, it's in process. We're hoping for 1.13 release to have it open sourced. So that's pretty much, overall the theme for the next week's 2 talks. So if anyone has any comment there, please, to let me know. We can edit here, update this thing in the notes. But other than that, any other discussions, if any open items folks want to talk. If not, I think we can call this a meeting. We will have a meeting after next week. So we'll have some updates from the KubeCon Shanghai in the following meeting. And, little updates from the next week's committee meeting as well. And then we continue doing the great things we do. All right, so no comments, then I guess we can wrap up the meeting if that's okay with everyone. Nimesh, you want to say something?
No comments. Thank you very much for hosting the meeting, and have a wonderful KubeCon next week.
Yep, thanks Rick.
Yep.
Thanks Nimesh.
Have a good time in Shanghai.
Yeah, thanks Khalid. Yep. Yeah, at least I see 3 folks, Brad, Mike going, so that'll be great. I know Nimesh, we'll miss you there. Wei, you as well.
Thanks. Take care. Bye-bye.
Yep. Bye. Thanks, Khalid. Bye, everyone.
See you, everybody.